So in the third of these videos for the Introduction to Chemistry, we're going to look at balancing equations. So chemical equations are going to show us what happens. Reactants are being converted to products. They're irreversible changes often, so we can't go back. We do occasionally get reversible reactions that we'll have a look at later. At GCSE you probably came across word equations a lot. Copper and oxygen make copper oxide. Copper and oxygen are the reactants, copper 2 oxide is the product. But at A level we do not write word equations. Everything is always a symbol equation, so we need to be able to convert word equations into symbol equations, and they must always be balanced equations. You cannot just write the symbols and leave it. You must always balance your equations. So they're going to give us the symbols and formulas, and they're going to balance for atoms. So first thing we're going to do is replace the words in our equation with the correct formulae. So we're looking back at our previous work from earlier on, and we're saying what's the correct formula for copper. So the first thing you need to ask yourself is copper one of those elements that just goes around as Cu, copper, that's its symbol, or is it one of the diatomic elements? Well, copper is not one of the diatomic elements, so we just write Cu for its formula. That's a capital C and a little u, just as it is on the periodic table. Oxygen is one of our diatomic elements, so it goes around in pairs, O2. And then copper oxide, formulas that we've just been looking at, an ionic formula, so copper 2, Cu2 plus, oxide, group 6, O2 minus. So if we're putting that together, the formula of copper 2 oxide is CuO, 2 pluses and 2 minuses balance. So we've got CuO. So we've written the correct formula down. Now we can adjust the numbers of these formulae without changing their formula. We cannot change these formulae in any way. So no more subscripts now, only big numbers in front, only stoichiometry. That's a fancy word for balancing the amounts. So we can only change the big numbers in front. So we have to make them be equal on both sides. Now there's lots of ways that you can do this, and you just need to work your way through. I'm going to check my metal. There's one copper on each side. And then I'm going to check the oxygens, but there's 2 oxygens on the left. So if I was to just copy that down for a second, and now I'm going to start putting some numbers in front. Because there's 2 oxygens in O2, I need to have 2 oxygens on this side, and the way to do that is to have 2 copper oxides, which then means I've got 2 coppers. So I need to go back and put a 2 in front of copper. And a double check, there's 2 Cus and 2 Os on each side. That is a balanced chemical equation, and I haven't changed any of the formulae that I've worked out. You can then add some state symbols. You only need to do this if the exam board asks you to do this. I wouldn't do this if I wasn't asked, but we know that copper is one of our solid elements, and oxygen is a gaseous element, and copper 2 oxide is a solid. At this stage we wouldn't necessarily expect you to know that. So have a go at balancing these 3. I'm going to pause the video and allow you to have a go, and then when you come back and you unpause the video, the answers should be there. There you go, I've had a go at balancing those equations and I've put in the numbers. These ones are a little bit more difficult because we're turning the words into symbols and balancing. So I'll go through the first one with you. We've got magnesium, which I know is Mg, oxygen, which I know is O2, and magnesium oxide, which we can work out. We know that magnesium is an Mg2+, because it's in group 2, and oxide is O2-, so it's going to be MgO. And then I can go and put my balancing numbers in, which would be a 2 here and here. So again, I'm going to pause the video, see if you can come up with the formulas of all of these. Now you might have to flick back through your pack and remind yourself of how to come up with the formulas, but see if you can come up with the formulas and balance these equations. Okay, so there we have a look at them. That magnesium one was very similar to the example from copper earlier on. Hydrochloric acid is HCl. I've worked out the formula of sodium carbonate using the ions and sodium chloride, and I've remembered the formula of carbon dioxide and water. Now a little trick that you might want to learn to balance equations that include acids, and this is a little rhyme. If you remember the words macho, then there's a little order that you can do things. If you balance the metal first and then Once you've balanced the metal, you can balance any other atoms. Some people might say the acid here, but I say any other that isn't carbon, hydrogen or oxygen. So we're going to go in this order. So I balanced the metal first. So there was 2 NAs, so I put 2 NAs on this side. Then I go for anything that isn't carbon, hydrogen or oxygen. In this case that's a Cl. So to balance the Cl, now that there's 2 Cls over here, there needs to be 2 Cls over here. And then I check the carbons, 1C, 1C, and then the hydrogens, 2 H's, 2 H's, and then the oxygens, 3 oxygens, 2, 3 oxygens. So again, because this is a reaction with an acid, we can use this again. Balance the metal. There was 2 lithiums on the right, so I needed 2 lithiums on the left. There were any other is our sulfur, 1 on each side. There's no carbons. The hydrogens balance, there's 2 on each side, and the oxygens, there's 4 on each side. Okay, so we're going to move on from balancing, but we're going to continue balancing by looking at just some of the words we use for different types of reactions in A-level chemistry. So the first one being combustion, and by combustion we mean burning it in oxygen, reacting it with oxygen. So methane, it's one of the ones you've had to memorise, and oxygen makes carbon dioxide and water, and if we use that Macho rule, we don't have a metal or anything other than carbon, hydrogen and oxygen, so we're just going to do the Cho part. 1 carbon, 4 hydrogens. We'll need 2 waters to make 4 hydrogens on the right. There's 2 oxygens on the right, and another 2 oxygens in the carbon dioxide, so 2 in the water and 2 in the carbon dioxide, 4 altogether, so we'll need 2 oxygens. Okay, the second type of reaction that you might hear about is called decomposition. Sometimes people confuse combustion and decomposition. Decomposition is when you heat it up, but you don't react it with oxygen, you just break it down, you don't react it. So we're just taking the one thing and breaking it down. So I'm going to pause the video, see if you can fill in the formulae and balance the equation. So there we go. It balances once you've put the formulae, you can see that it balances. Next one is a neutralisation, so acid and alkali or acid and base to form water. So again, pause the video, have a go and come back and see whether you've got it right. Hopefully if you've got this correct, you should have got that. Sodium hydroxide, NaOH plus HNO3 makes NaNO3, sodium nitrate and water. So redox reactions, reduction and oxidation combined. Again, you'll have come across these at GCSE, although you might have called them displacement reactions. There's 2 here for you to have a go at. Again, using all the rules for creating formulae and then balancing equations. See if you can write equations for these 2. There we go, there are those last 2 there. Magnesium and hydrochloric acid makes magnesium chloride and hydrogen, and chlorine and potassium bromide makes bromine and potassium chloride. So we've had combustion, burning in oxygen, decomposition, heating to break it down, neutralisation, acid and alkali reacting together to make water, and redox, reduction and oxidation taking place together. One element is losing electrons, another is gaining. So in our top example here, magnesium is losing electrons to become magnesium ions, and the hydrogen ions in the acid are gaining electrons to become hydrogen gas. So hydrogen ions, H+, have no electrons, and in the hydrogen gas there's a shared pair, so there are 2 electrons in there, in H2. And here we've got chlorine gaining electrons to become chloride ions, and bromide ions losing electrons to become bromine. These are redox reactions. Other words that you might come across are exo and endothermic. Exo meaning heat out, the exit is the way out, the therm is the heat. So we're going to release heat to the surroundings. Which reactions give out heat? Well, any kind of burning would. So carbon and oxygen, carbon burning in oxygen to make carbon dioxide, that balances as it is. And an endothermic reaction is any reaction that takes heat in from the surroundings. So quite often you have to use a Bunsen burner or a source of heat to make these work. Hydrogen iodide, HI. Hydrogen is diatomic, as is iodine. So to balance that, I would need 2 hydrogen iodides. So we've had different types of reaction, and then words to describe the energy involved in reactions, exo and endothermic, and then there's another word, reactions that are reversible. We see this arrow here. This arrow here representing that the reactants can form the products, but the products can be reverted into the reactants, so this can happen in either direction, and all three things will be present at any one time. So sulfur dioxide, oxygen, sulfur trioxide, and then we need to balance that. Now to make the oxygens balance, given that that's a 3 and this is a 2 and a 2, so that's 4, we're going to have to try to make 3 become an even number. I'm going to put a 2 in front of that, that's going to give me 6, but I now need 2 sulfurs, and now I've got 6 oxygens on each side. You can, this is just a little point, some of you might prefer to do this, balance it in a different way. This is just something extra that you might prefer. Another way to balance it is there was 2 oxygens and 2 more, and we only needed 3. If I put a half a mole of oxygen gas there, then that would be in total 3 oxygens on the left. And students often say we can't have half an O2, isn't that just an O? We're not talking about half of 1, we're talking about half of 1 mole, and 1 mole is millions and trillions of them. So we can have a half in our balanced equations if we like. You'll learn lots more about reversible reactions later in the course.